Hello everyone. In our last class, we discussed special angles and we talked about one of the special angles, which is angle 45. So in this class, we are going to be discussing the two other special angles, which are angle 30 and angle 60. Okay, so let's think of an equilateral triangle. You know, equilateral triangle, all the angles are equal and all the sides are equal. So let's think of an equilateral triangle with the side of 2 units. Okay, so this is 2, this is 2, this is 2. Then since all the angles are equal, each one will be 60 degrees, 60 degrees, 60 degrees. Okay, so supposing we cut this triangle into two equal halves. Okay, it will form a right angle here and it will form two right angles. This is one of them and this is one of them. Remember, this place was angle 60, so we divided it into two. Okay, so that is to say that each side will be 30 degrees. Okay, so you can see we have two right angles, which are 30, 60, 90. That's how we got this name, 30, 60, 90 degree triangle. So let's bring out one of the triangles. So supposing I have this, okay, this is a right angle triangle. This place is right angle, then here is 30, then here is what, 60 degree. Okay, remember the side we have, since from here to here is 2 and we divided this line into two equal parts, this place will be 1, this place will be 1, so we have 1 here, but we don't have the other length. We are going to determine that using Pythagoras theorem. Okay, so we have that 2 squared, which is hypotenuse squared, equals, let's level here x squared plus 1 squared, that is here. Okay, the square of the hypotenuse side is equal to sum of the square of the two other legs. So we have that 2 squared is 4 equals x squared plus 1 squared is 1. So 4 minus 1 equals x squared. Then 4 minus 1 is 3 equals x squared. You take the square root of both sides to remove the square. So this will cancel this and we are left that x equals root 3. Okay, so this place is now root 3. So we are going to use this to find the trig ratio of angle 30 and angle 60, and they are what? Special angles. So let's start with angle 30. Remember our SOHCAHTOA. SOHCAHTOA. Okay, we are going to start with sine. Sine is opposite of a hypotenuse, and we are starting with this angle 30. If you are considering angle 30, then the line opposite it is the opposite. So this is the opposite. Then any line opposite the right angle is always the hypotenuse. Then this other one is adjacent. Okay, all right. So sine 30 equals opposite of a hypotenuse 1/2, so 1/2. Then cos 30 equals adjacent over hypotenuse, adjacent root 3/2. So we have root 3/2. That's the value for the ratio for cos 30. Then tan 30 equals opposite over adjacent. Our opposite is 1 over what is our adjacent? Root 3. Okay, you can decide to rationalize this. All right, so this is all for the three main trig ratios of angle 30. Then let's move over to 60. If you are considering 60, then this place now that is opposite that angle in question will be the opposite. So this is now opposite. This is always the hypotenuse. Then this place will now be adjacent. Okay, all right, so we'll start with sine 60 equals opposite over hypotenuse, opposite root 3/2. So we have root 3/2. Okay, then cos 60 equals adjacent over hypotenuse, right? Our adjacent is 1. 1 over hypotenuse is 2, so 1/2. Then tan 60 equals opposite over adjacent. Our opposite is root 3 divided by adjacent is 1. So this is basically root 3 over 1 is root 3. So tan 60 is root 3. So with this, you don't need to start memorizing the, what is it called? The trig ratios of these special angles. You can easily determine them using this method. Hope you learned something new today. Thank you for watching. Bye.